All right, so this lecture is on standing waves. So a standing wave is a wave that remains in a constant position. So they look like this, right? These are what standing waves look like. This first possible one, this is referred to as the first harmonic or the fundamental frequency. Fundamental meaning like basic. First possible frequency gives a standing wave that looks like this. Now this one here is called the second harmonic. This is the second possible way that a standing wave can be generated. Now the terms are, well, here's the third possible one. That's called the third harmonic. Now notice here we have A and N. So what does the N stand for? Node. What does the A stand for? Antinode. Okay, so the antinodes are here. So antinode, antinode, node. The node is where the wave is not moving. If you look at the standing wave that I have set up on that wave generator over there, the nodes are at the ends, right? So look, we have node here, and we have node here, and then there's an antinode in the middle. Okay, so what we're going to go over is how you calculate the possible frequencies for a standing wave. So what I did is I figured out, oops, I didn't want to do that. Cancel that. So what I did is using that wave generator that's set up right there, I figured out that the first harmonic is 7.5 hertz. So what we're going to do is we're going to look at, well, if the first harmonic is 7.5 hertz, what would be the second harmonic, and what would be the third harmonic? So there's a frequency that we can set the wave generator to that's going to give this, and then there's a frequency we can set the wave generator to that's going to give this. Okay, so I'm going to show you how to do it. So let's go to this, let's go to a blank screen. All right, so the first possible wave, it's the first harmonic, or called the fundamental frequency. It's when the wave vibrates like this. Okay, now the length of the string is L. Okay, so from end to end is L. And how many wavelengths does this wave represent? So with this wave here that you're looking at, how many wavelengths is this? So let me help you figure it out. So here's a wave like this, right? Wavelength, the best definition is from one point on the wave to the next identical point. So on this wave, that would be a wavelength. So what are we looking at right here? How many wavelengths would that be? Well, it looks like this. It goes boom to boom. So how far would that be? That is exactly what? Half of a wavelength. That's wavelength over 2. So in this case here, L is equal to wavelength over 2. So what's the wavelength going to be equal to? 2L. Right? Where L is the length of the string. Okay? Now, the wave equation. Velocity is wavelength times frequency. So what's frequency? Just rearrange the wave equation. Frequency is going to be velocity over wavelength. And just keep in mind, the velocity of a given wave is constant for a given medium. And we're not changing the medium here. That's just a string vibrating because the wave generator's creating a wave in it. Right? So the velocity is constant. So check it out. So frequency 1 is going to be the velocity of the wave over the wavelength. But what's the wavelength for the first possible frequency? The wavelength is what? 2L. So we get this equation of V over 2L. Okay? Oh, and I figured out, just trial and error, I figured out that the first possible frequency is 7.5 hertz. Okay, so that's what that wave is vibrating at, the one you're looking at right there. And if you're watching this at home, you can't see the demo, but trust me, we have this wave set up right here. This wave's going like this. It's going do-do-do-do-do-do-do like that at a frequency of 7.5 hertz. Okay. Now, second possible frequency. Now, dudes, so again, we got our 2 endpoints. Now, what's the next possible way? What's the next possible way that this wave could vibrate? So we're going to have node, right? The ends are always going to be nodes. And then how many nodes in the middle? 1. So this is going to be the second frequency, right? F2. Okay, so this wave looks like this. It goes boom, like that, and it's oscillating like this. So that's a node. That's a node right there, and then this is antinode right here. Now, the distance from end to end, that's the length of the string, that's L. How many wavelengths does this represent in this diagram? That's exactly 1 wavelength. So L equals lambda here. Okay, so let's figure this out. So F2, what's the frequency equation? Frequency is V over lambda. So this is going to be V over lambda. But what is lambda? Lambda is what? L. Okay, so we get V over L. Okay, and then this is V over 2L. So check it out. If we want to go from the fundamental frequency, from the first frequency, which is 7.5, to the second frequency, compare these two values here. So we got V over 2L and then V over L. So what do we have to do to get to the second frequency? Take the first frequency, and what are we doing here? We're basically what? Timesing it by 2. All right, Caleb, take us from 7.5 hertz on the wave generator, and let's see, 7.5 times 2 is, don't tell me, 15. Take it to 15 hertz. Let's see if it works. Shh, let's see if it works. Bam! Did it work? Yes. Yep, you are now looking at this wave right here. Okay, we are looking at the second frequency. Okay, so let me shrink this down. Now we're going to go to the third frequency. This is really pretty awesome when you think about it. Okay, the third possible way that this wave can vibrate. So now look, how many nodes did this guy have in the middle? 1. So the third possible frequency is going to have how many nodes in the middle? 2 nodes in the middle. So it's going to go like this. So the wave's going to, and the ends are always nodes. It's going to go like this. It's going to go boom, 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 like that. So the wave is going like this. Now, the length of the string is L. How many wavelengths are in there now? Let's see. So from here to there, how many wavelengths is that? How far is that? That's 1 wavelength plus how far is this? That's half a wavelength. So how many wavelengths are in here? 1.5, 3 over 2, right? So the length of the string is 1.5 wavelengths. So here, I need a little more room. So what's lambda going to be equal to? So wavelength equals what? 2/3 L. You guys with me? Okay, so what's the third frequency going to be? So frequency is V over lambda, but what's lambda here? Lambda is 2/3 L, so this is going to be 3V over 2L. So how do we figure out what this third frequency is going to be? What should we compare it to? Should we compare it to F1 or F2? I would compare it to, I think it's easiest, well, you know what we could do? We could take this and go boom. What's the relationship there? V over 2L, 3V over 2L. What do we do from here to here? Times it by what? 3. Or you could go from here to there. What do we multiply there? Times 1.5. So either one. So look, what's 7.5 times 3? So the third frequency should be what? 7.5. Multiply that by 3 because this is 3 times larger. What's that going to be? 22.5. Or you could have gone 15 times 1.5. Again, 22.5. All right, Caleb, take us up to 22.5. So currently the wave is vibrating at 15. Take it to 22.5. Bam! All right, did it work? Yes. It worked. Okay, last one. I've never seen a question beyond the 4th frequency. So we've gone up to 3 already. So now let's shrink this even smaller. Or actually, you know what? Let's do this. Scoot that. Oops. Oops. Darn it. Dicky do. Come on. Get rid of that. Let's go like this. Just shrink that down. Good enough. Okay. The fourth. The fourth possible harmonic. How many nodes are in the middle? 1, 2, 3, and then nodes are at the end. So the last one goes like this. Boom, 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 boom. How many wavelengths are in here? So here this is L. How many wavelengths are on that string? 2 wavelengths. So what's the wavelength going to be there? Wavelength is going to be L over 2. So let's figure out the fourth harmonic. The fourth harmonic, we go V over lambda, but lambda is L over 2. That's L over 2. So the fourth frequency is 2V over L. Am I breaking your brain? So let's compare this to what? Let's compare it to what? Let's compare it to the second. So what was the second harmonic? V over L. This is 2V over L. So what do we do going from here to there? What are we doing? Multiplying by 2. So what should the fourth harmonic be? 30. Caleb, take it up to 30.
Oh boy.
And bam. There's 3 nodes in the middle. All right, do you guys get the idea? Now look, I got to tell you, I've been teaching this a long time. Do I have these frequencies memorized? Like, you know, how do you go from the first frequency to the third frequency? Do you think should you memorize that or be able to figure it out? I'd be able to figure it out. I would not memorize it.